Today I want to show you a project which I think could be easy even for a beginner maker to put together, because it only requires a few hardware components, mostly things that are available off the shelf from eBay and other Chinese sources, and which also requires very few tools on the software side. I know I said in the title that no programming is required. Well, actually you need to do some sort of programming, or at least copy and paste code from my example, but at least you don't have to set up a development environment, worry about buying libraries and other dependencies. So I think from an overall perspective, it's still a very easy and a very quick project to put together. And what I have here is basically a thermostat, and I think it has all the necessary components for a thermostat, which means that, well, we have some sort of processor which does all the logic and the calculation. We also have a display, so we don't necessarily have to use our phone to set a temperature. We have a temperature sensor, and we also have an actuator. So in this case I have a relay. And I set this project up so you can use it to control, for example, your heater. So you set a certain temperature that you want in a room, and if the ambient temperature drops below that, it will start the heater, for example, a boiler or a furnace or something like that. And once the temperature has gone above that set temperature, then it's going to automatically turn off. And as I said, this is like a self-sustained system, even though it is connected wirelessly to my home network, and it's also connected to my MQTT server, and it's sending data in, but all the logic is contained within this ESP8266, so it can operate on its own. For this setup I'm using an ESP8266 which has an integrated 0.96 inch OLED display, which means that this display is really tiny. So I had to zoom in a little bit so you can see the details. And besides the ESP and the OLED display, we have two buttons that allows us to control the set temperature, so we can increase the temperature or decrease the temperature. And we also have a temperature sensor. In this case I have the HT22, a temperature and a humidity sensor. And also we have a relay. I happen to have these 4-channel relays, but we are only using the first channel out of this one. And as you can see on the display, you see the current temperature, so it's 23.4 degrees Celsius and 42% relative humidity in the room, and we have a set temperature of 20 degrees. So we want 20 degrees in the room, and because our set temperature is lower than the current temperature, the heater or whatever device that we are controlling is off. And we can see some other information here, which is the current IP address and the uptime. So this setup is now running for 16 minutes. In order not to write any code in, let's say, an Arduino IDE, for this setup I'm using ESP Easy, and I have programmed and configured the entire functionality within ESP Easy. Just to show you how it works, well, it's pretty simple, because basically we just have two buttons. So I can use this button to lower the set temperature by 0.5 degrees, and if I press the other button, then it goes up by 0.5 degrees, and at some point, once we go above the set temperature, not yet, and not even now, but if I set it to, let's say, 24.5, the reason I'm setting this high, because I've actually built in a little bit of buffer, so it only turns on 0.5 degrees above the set temperature and turns off 0.5 degrees below the set temperature. So just to avoid any of your device switching on and off. That also means that there is a buffer of 1 degree, so in the code you can just reduce that to, let's say, 0.1 or 0.2 degrees. And as you can see just at the top of the screen, the relay has come on. So now we have the heating on, the relay is on, and you can control whatever you want, for example your boiler, so it starts the heating. And of course, once the temperature rises, then once it reaches, let's say, 25 degrees in this case, then the relay is going to go off. So very simple, but this is what you usually need in a basic thermostat scenario. I pick thermostat as an example because in a typical home automation, the first thing that you most probably want to control is your room temperature, so you want your heating to go on and off. But of course you can use it for air conditioning, so control cooling. But because we are using ESP Easy, and ESP Easy supports a number of different sensors, you can use it to control something based on another system variable. So I already have here temperature and humidity sensor, so I can use the humidity to control, let's say, a fan to keep a particular room dry, but also you can hook up other gas sensors and other sensors. And switching from this sensor to a different sensor is quite easy because we are using the ESP Easy framework, and the control theory is all the same. You have a set value and you want to keep your actual value in between those set values. Let me talk a little bit about the hardware. As I said, I'm using this ESP Easy, which has this built-in OLED display, just because I had this laying around. I was planning to use it in a project, which I haven't started doing yet. So it was just a good idea to use it because, well, I just need less wiring because the OLED display is already wired in. Of course, this screen is quite small. You can easily buy 1.33-inch displays, which has the same resolution, so everything is going to be a little bit bigger, and they need to be connected exactly the same way as this one. Besides the OLED display, we have two tactile switches, and again, connecting this is really easy. As you can see, I've used the ground connection, which is here on this ESP. I connected it to the top rail, and then using these two jumper wires, I've brought down the ground to these push buttons, and once the push buttons are pushed, then the signal goes back via these white wires, and they go to, what is it? I think it's D7 and D6. I've used D5 to connect the DHT22 temperature and humidity sensor. So this sensor has 4 legs, and then the left most leg is 3.3 volts. So you can see the 3.3 volt jumper to the positive line, and that's connected to 3.3 volts. The rightmost leg or rightmost pin is ground, and the second pin from the left is the data. So that is connected directly to D6. And then between the 3.3 volt and the data line, you have to put a 1K resistor, otherwise the readings are not going to work. So that's the buttons and then the temperature sensor. So the only other thing I had to connect is this relay. So as I said, I'm using this 4-channel relay board, but I'm only using 1 channel out of it. And this board requires 5 volts. On this particular ESP, I have a 5 volt output, but most of the ESP boards like the VMOS has a 5 volt output. So that goes to the VCC. Again, ground goes to the ground. And I use D3, which goes to the in1 pin. And these relays, and most of these relays, are active low, so they actually switch once the input is on ground. And if the input is on 3.3 volts, then the relay turns off. So we just have to take that into account in our code and then setting up this ESP. Now let's go through the process how you set up this particular ESP and use ESP Easy and implement all the functionality that you see here. For this project, I'm using ESP Easy because, well, after all, this is my favorite firmware for the ESP8266. But besides that, because the ESP Easy has this rules framework or this rules whole concept, which allows you to create simple programs or script within the ESP Easy, so you can customize how your ESP works based on the scenario that you need. And actually, I'm implementing all this functionality within these rules in the ESP Easy, which is great because it's all can be configured and changed over the web, so you don't need a separate programming tool like Arduino IDE, and you don't have to set up libraries and all sorts of stuff. So it's quite easy. You just install the firmware and then you just edit the code online. And secondly, this allows this particular device to work on its own. So it does not require any external home automation system, for example, an OpenHeader or Node-RED or Home Assistant, to fulfill its basic functions. So it can do all the switching and changing the temperature, the set temperature, and also displaying all this information as it is. So it is connected to the USB at the moment only for power, and it's connected to MQTT because it's sending out data. But besides all of these, all the code and all the functionality is running on the ESP. First, we need the ESP Easy, and I just usually Google ESP Easy, and then it takes you to this site, which is www.letscontrollit.com, and here you can go into loading firmwares, and as you can see, there are a couple of different firmware versions available. In my past videos, I use release 120 or 147, but now there is a new version coming up, which is version 2.0, which is release candidate at the moment, but I still decided to use this one. I'm not really sure if I'm going to use any of the new functionality, but let's just try with the latest release. And at the moment it is 2018-11-12, so it's actually just a couple of days old. So you download the zip file and then you extract the zip file into a folder, and you will have a couple of files and a couple of folders. And the only thing you need to remember is to run this ESP Easy Flasher. In the past we flashed ESP Easy using a command line utility. Now they have provided an executable file, so it's even easier than before. What you will notice on the top of the screen that the program runs through all your COM ports, and then, well, for me, I have the mouse and I have the ESP Easy connected, and it automatically switched to the ESP Easy. I don't know if it can detect it based on the chipset or something, but anyway, you will have all your COM devices here. You have to select the one where the ESP Easy is connected. And the next thing is you need to select the firmware. And in the drop-down you see quite a few different firmwares. You have some test firmwares, you have some normals and dev and some other stuff. So we are going to use the normal. And out of the normal ones, initially I used the one which says 4096, because this particular ESP has 4 megabytes of flash. But it wasn't working perfectly, and I don't know whether it's an issue with the device or the issue with the ESP Easy. So I've just gone back to the flasher program and I just selected the one below. So that's the ESP_Easy_Mega, the date _normal ESP8266_1024.bin. Next, you have a couple of options here, which I think I have configured incorrectly. So you can set up the SSID and your SSID password here, which didn't really do anything for me. I probably should have pressed this post flash action or tick this post flash action, which I didn't. So it didn't actually save my SSID and the password, so I had to do that manually. But, well, that's not a big deal. You can do it either like entering it here, probably tick this post flash action, or you just do the setup afterwards. The only thing which is left is you click on the ESP Easy, Flash ESP Easy firmware. Remember to flash an ESP8266, on some boards there is a flash button, or for example on the Son of One you have to press the button in order to get to flash mode, and that exactly happens on this device as well. So we have a flash button up here on the top right corner. So before you flash it, disconnect it from the USB, click this button, connect it to the USB, then you can release the button, and then only after that you can click on this Flash ESP Easy. Otherwise you would get some error messages. And you just wait for about 1.5 minutes and your ESP is going to be flashed. I'm not going to show you the Wi-Fi setup here because I've already done that, and probably you can see it in previous videos, but once this is done, you will see that an ESP_Easy_0 Wi-Fi network will be created. You connect to it using the config ESP, all lowercase, one word, password. And once you have done that, you go to a website, you open your Internet Explorer or Chrome or whatever, and you go to 192.168.4.1, where you will present it with a simple setup screen where the ESP is going to show all the Wi-Fi networks that are available in your area. So you just select your home Wi-Fi, you specify your password, and you click on the connect button. And after about 20 seconds, it will connect to your Wi-Fi network, and it's going to give you the IP the ESP has received from your router. And then you just go to that website. And for me, that's 192.168.1.117. which I have configured to be printed onto the Oled display. So while we have the ESP Easy Mega set up now, I just want to quickly go through the codes or the settings. So these are the settings that you also need to do. The first is we go to the config page, and here the only thing I've done, I just renamed the unit to, let's say, ESP Oled. It's not strictly necessary. It is good to have a specific name if you are using MQTT. Otherwise, you don't really need that. And the rest of the settings are pretty much self-explanatory. If you are planning to use local IP, you can set the local IP here. I just use global IP, or sorry, DHCP. Next page is the controllers. I'm going to show you in this video how I'm receiving data via MQTT, but again, just to use the stock functionality, that's not really required. If you're planning to integrate it with a home automation system, I think it's good to have MQTT. So if you have that, you can set it up here. I use this OpenHub MQTT, and that's my IP and the port and the user ID. So they are all detailed here in the edit. Don't forget to enable the controller. The next is the hardware, where I made a couple of changes. So first of all, on this particular model, I'm not sure what the default setting was, but the status LED is GPIO2 or D4, and that's the blue LED that we can see here. Next was the I2C interface, and by default I think they are using D4 and D5, but this particular mode is using D1 and D2, and it was actually quite difficult to figure it out because it's not listed on any of the, like eBay listings, but I actually had to flip the board around, which is easy, but since it was already socketed, I didn't see the back of the board. But it is printed on the back that they are using D1 for SDA and D2 for SCL. Next, we have to set up some of the GPIO pins and the boot states. So out of the GPIOs, we are using D3 for the relay, and that's D3, which is going into the in1 of the relay board. And because this relay is active low, I set it to output high. So the default state is high, which means that the relay is off. And by the way, when you power cycle the ESP, on this particular pin, the relay is going to come on for a split second. And that's, I think, has to do something what is the default state of this pin. But I couldn't do anything about it, so I just set it to output high. And after that, or besides that, I'm using D6, D7, and D5. So D6 and D7 are the two buttons, so the up-down button. So those are the two, white leads that are going off D5 and D6. Sorry, D6 and D7. And D5 goes to DHT22 temperature and humidity sensor. That's the green lead that you see here. So all of them are input. So I set them to input. Next are the devices, and we have a couple of devices, and they are mostly the actual physical devices that are connected to the ESP besides this second one. So the first and probably the most obvious one is the Oled Display. So the device here that you need to configure is the Oled SSD1306. I mean, in this board we have an SSD1306 OLED. If you find any cheap OLED, they are usually the same type. It works on a default IC squared address of 60. I selected the rotation to rotate it because otherwise the screen was upside down. Font size is this, and font width is, I tried switching between normal and optimized. I haven't seen a difference, so I left it on optimized. And within the ESP Easy framework, the OLED displays are handled as, I think it's a 16 by 8. So basically you have 8 lines you can print to. And this is, well, to some extent a limitation in the ESP Easy framework, but you can only configure the screen to have these 8 lines. So you can't use fewer number of lines with a bigger font. That's how the firmware is written. So I decided to do a couple of things. In line 1, I print the temperature, and then degrees centigrade or degrees C, and then the humidity percentage. That's what you see on the first line. And whenever you want to print a value, which is a value from a device, then you have to use the square brackets and then the device name and then hash and the value name. So we will see, once we go to the next device, we will see how that looks in the configuration. So DHT22 temperature and DHT22 humidity. On the second line, I'm not putting anything. Into the third line, I'm putting a text which says set temp : and then the value of the local hash set temp. So it's again a device and a value. There is nothing in line 4 and 5. In line 6, I just have a number of lines which appear like a divider. And then in line 7, I have the IP address, and then below that an uptime. If you search on ESP Easy commands, then you will find a reference where it shows you all the different commands that are available. There are tons of them besides these two. And probably the last important settings here is the interval. That's basically 1 second. And this tells ESP Easy to refresh the screen in every single second. And the reason this is important, I think the default value is 60, because even though the temperature and the humidity doesn't change very often, neither the IP or the uptime, but whenever you press a button, either the up button or the down button, you will notice that the screen doesn't update immediately. There is a little bit of delay. And that's actually something to do with the interval, because when you press these buttons, the temperature gets updated, but it only gets updated on the screen in the next update cycle, which is 1 second. You can't go lower than that. The next thing is, or the next device, number 2, is the generic dummy device. And you can use generic dummy devices to store your own values. So these are like your local variables. So I call them local, and I have 3 of them: set temp, temp low, and temp high. So set temp is what you see on the second screen, so that's 20 degrees. And set temp low and temp high is always half a degree above and half a degree below that set temperature. And if you remember the screen where I printed the OLED screen configuration, where I printed my set temperature, I use square brackets local, so that's the name of the device, and hash the value name set temp, and then end square brackets. So this is how you reference to a device value. The only other thing I've done is I tick this send to controller, and the interval is 60 seconds. So that means that in every 60 seconds, the value of these devices will be sent all over to the controllers. So the controller for me is MQTT. So this data, it gets sent to MQTT every 60 seconds. The next device is the input switch. And obviously we have 2 of them. So the first one is the up button. So the name is up. It's enabled. There is an internal pull up. So by default, it's 1. And then when it's pressed, it goes down to 0. And for the up, we are using D7, and it's a switch type, and it's a normal switch. And I've also put a debounce, so it doesn't get triggered twice when you, or multiple times when you press it. And yeah, that's it. There is no point sending it to a controller or use the interval here. And as you can see, it's name up, and the value is switch. This will get used later in the rules. And the down is very similar, so it uses exactly the same settings. Obviously, the GPIO is different, but everything is the same. Well, for some reason the debounce is different, but 50 and 10 still works. And the last device we have is the DHT22 temperature and humidity sensor. The device is obviously the environment DHT111222. Again, it's enabled, it's connected to D5, and it's a DHT22 type. And here I have interval set to 15 seconds and sent to controller. So these 2 means that every 15 seconds the ESP is going to check for the temperature and the humidity. So it gets updated every 15 seconds, and whenever it gets updated, it also gets sent to the MQTT controller. And it has 2 values, temperature and humidity. And again, if you remember how I referenced to these values in the OLED configuration, so again, square brackets, the name of the device, which is DHT22, hash the name of the value, which is either temperature or humidity, and then close square brackets. So that's all there is to it, to how you configure your devices, and then how you configure your OLED screen. And again, as I said before, this particular implementation is using a temperature sensor and a relay, which let's say controls a heater or a boiler. But you can swap this environment sensor to a different environment sensor, so you can monitor, well, we are already monitoring temperature and humidity, but you can also monitor like even pressure or a gas content or something else, and then do controlling something based on that level, whether it's above or below a certain threshold. I'm just using this thermostat example because I think that's the easiest to understand for most of us. Before coming to the rules, which you wouldn't see in the beginning, let's go over to tools, and in here I usually go to advanced. And the first and the most important thing is to enable the rules, because by default it's not enabled in a new ESP Easy installation, and we are definitely going to use that now. Other than that, I enabled NTP and I put the NTP server and I put the UTC offset. I'm in CET, so that's 1 hour behind a UTC, so that's 60 minutes. I'm not using the NTP or the time functionality at the moment, but I usually just do that in case I need the the proper date and time in my ESP. So the last thing we need to do is we need to go into the rules. And in rules, you configure your, let's say, special functionality or bespoke code, which is going to make this ESP different from any other ESP installation. And as I said in the beginning, this example or this project doesn't require programming. Well, this is actually programming, so I was lying just a little bit, but at least you can do it over the web. You can easily change it anytime. You don't need any other application to do that other than your browser, which you would need anyway to configure this device. If you want this particular example, you basically just copy and paste these rules that I put into the video description, and you don't have to do anything on it. But I'm going to go through each line of them and explain you what it does so you can make this work in your particular scenarios, because there are a couple of assumptions here that you might want to change to better suit your requirements. So the first thing first, the first block is this on and end on section. It says system boot or system hash boot. So that gets executed every time the ESP is started. And I'm using this to set some default values, mostly because there is no way to store these local variables, and my local variable is basically my set temperature, and I can't save it. So if you lose power, if you restart your ESP, it technically goes back to 0. So instead of having a set temperature of 0, I'm setting it to 20 degrees. And you do that by saying task value set 2,1, 20. And the reason we do 2,1 is basically how you set up your devices. So the first number 2 is the task number, and the second number 1 is the value number. And you can see it here. If I go to the dummy device, oh no, actually I have to go back. So the task number is 2, so that's the number for this whole dummy device. And then the value is 1. So 2.1 is set temp, 2.2 is low temp, 2.3 is temp low and temp high. And that's what I've done here. So set temperature is 20 degrees, the low threshold is half a degree below, and the upper threshold is half a degree above. The next one is on, the next on and on section says up hash switch. So that gets executed whenever the up button is pressed. So the value of the up hash switch, which is the state of the up physical button, gets changed. First, I'm checking whether this value is 1, which is actually, it will get 1 when you release the button. I could have put 0 here, I guess. Doesn't make a whole lot of difference. Next, I check whether the set temperature, which is local hash set temp, is less than 40. This is just to prevent anyone to set the set temperature above 40 degrees, and then it needs to go back down. Again, it's not entirely necessary. So if the temperature is below 40 degrees, then we can increase the temperature by half a degree. So my new set temperature, or yeah, my new set temp becomes the existing set temp plus half a degree. The low becomes the current one, and the high becomes the current one plus 1. Straightforward. The down button functionality is exactly the same, so we are checking if the down switch is 1. We are checking if it's above 5, so we don't want to go below 5 for a heating example. And we are setting again the set temp and a temp low and a temp high. So it's the current value minus 0.5, that's the new set temperature. The low is the current one minus 1, and the high is the current one. Straightforward. In the next block, we are doing something whenever we get an update on the DHT22 temperature. So here it says on DHT22 hash temperature. So if we receive a reading, So that basically gets executed every 15 seconds because that's the interval on the DHT22 sensor or device. So if the temperature is greater than the temp high, then it starts the event which is called the turn off. So as you can see it here, if let's say the room temperature goes above the higher threshold, which in this case is going to be 20 plus 0.5, so 20.5 degrees, then it calls turn off. So it's going to turn off the boiler. And also if the temperature goes below the temp low, so in that particular case, it's going to be 19.5, it's going to call the event turn on. So that's going to turn on the boiler. I guess I could have copied these two if statements into the same on and on, but again, it doesn't make a whole lot of difference. So as you can see, this logic is for, controlling some sort of heating device. But if you want to control a cooling device, for example, an air conditioner, you just have to switch these signs because then you want to do it the other way around, obviously. And as I said here, we are calling two events, which is the turn on and the turn off, which we have specified here. So on the turn on event, we are setting the GPIO 00. So 0 is the D3. Unfortunately, GPIO numbers and the D numbers are not the same. So D3 is actually GPIO 0 and it's 0. And as I said, this relay is active low, so it switches on when the signal is low. So that is going to turn on the relay. And I'm also issuing this command, which is basically going to write this heating on string onto the OLED display, and it's going to put it on row 4 and column 2. And that's what we see in row 4 there. And for the turn off, it's pretty much the same, but we are sending GPIO 0 to 1, and then we are printing the heating off. So up until now, I think it's fairly straightforward. So the last thing that we do here, or the last piece of code, is an set temp do, and then it again updates the set temperature and the temp low and the temp high. And as you can see, this is not like a device because it doesn't have a hash, so it's an event, just like the turn on and the turn off. And that's something that we can use to externally set the set temperature, which is going to look like you call a URL which starts with your IP and then /control $CMD equals event. So we are going to call an event, set temp, that's the name of the event, and equals 15, that's the event value. So if I do that, sorry, not 15, 25. What you see here is that the screen updates. So now it says the set temperature is 25. And because it's well above than the room temperature, the heating comes on. And that's what actually executed here. So we call this set temp event, which we have defined in the rules. And then we are setting the task value 2,1, which is our set temp, to the event value. And the event value is this value after the equals sign. So you can use this event and this URL to set your temperature from an external application. So that can be your home automation system. And most of the home automation systems like, OpenHAB, Node-RED, Home Assistant, they support, calling a URL based on, whatever user input that you do on the home automation screen. So with this few lines of code here, besides being able to change the set temperature manually using the buttons on the device, we can also integrate it and enable that set temperature to be set externally. And by the way, what I wanted to explain now is, you see, I changed the set temperature, and I just have to wait a little bit before the relay reflects those changes and updates the relay status, or sorry, before the ESP updates the relay status. And the reason this is done, because here, if you remember, this is the piece of code which determines whether the relay needs to be on and off. And that piece of code only gets executed if the temperature is updated. So that's every 15 seconds. If you are changing the set temperature in between those 15 seconds, then, nothing really happens until the next temperature update. And also I wanted to point out that Here we have this simple if statement which says that if the DHT22 temperature is greater than the local temp high. So here I wanted to say local set temp plus 0.5, but the rule engine doesn't support any complex expressions here in the if statement, so it can only be a fixed value or a device ID. So I actually had to generate this temp high and the temp low as separate values so I can use them in the if statement. So that's the only reason I have 3 values here and not only 1. I hope this explains how this device works and how you can put it together for yourself, and most importantly how you can customize it for your particular needs. I hope you agree that this is an easy project, both from the hardware and also from the software point of view. I really think that ESP Easy really excels when it comes to adding custom logic to your ESP, and that can be so easily implemented using these rules. Again, you don't need a separate application, you don't need an Arduino ID, still you are doing some sort of coding, but I think it's way easier to do this than doing the whole thing in Arduino ID. Not to mention that you always have access to your ESP Easy config. Like here, you just need a web browser, you can do it from your phone. So if you need to make small changes to the code, you can just easily do it and then submit the changes, and then you are done. And finally, I just wanted to show that within my node I did a really simple flow which basically just listens to ESP OLED hash messages, and then it prints them here. And I just wanted to prove that all the values are coming through. So you can see the DHT temperature, humidity readings coming every 15 seconds, and about every minute. We also have the set temp values coming through as well. So you can use these values to show them in your home automation setup. So if you have like a dashboard or some sort of front end running on your phone, you can see all your room temperatures and your set temperatures. But also whenever you walk up to the device, you can see the same settings on the OLED screen as well. Thanks for watching, and hopefully see you in the next video.